Amateur astronomers have discovered it's raining molten iron on an exoplanet. Well, Dr. Brad Tucker and I are going to go in-depth on this Talkin' Science Story of the Week.
Across Apple Podcasts, Spotify, Google Podcasts and YouTube, this is Talking Science with Dr. Brad Tucker and Matt Miller.
Scientists have identified molten iron rain on this exoplanet that we teased last week.
Yeah, WASP 76b. The announcement came out, as we highlighted that it was going to come out. And this temperature, let's just say you are glad when it's a drought. You do not want rain on this planet. So this planet, it's been detected to have iron in its atmosphere. Now, the way you get this is the daytime temperatures of WASP 76b are 2,400 degrees Celsius, hot enough to actually break iron into the individual atoms. But the planet has a wind system and it blows the iron around just as we do here on Earth. And as it goes into the nighttime being a balmy 1,500 degrees Celsius, it solidifies. And when iron solidifies in the air, it falls to the ground. It rains iron. Like, I can't even imagine raining iron.
You'd have to be an iron collector to be excited to go here.
Look, I mean, this is Iron Man's planet. Like, this is Iron Man's home world. This has had to be where theoretically a true Iron Man would have been created. And you just kind of get the idea and imagine how big and how much of a change you get, that the differences between daytime and nighttime are so extreme, and the way you'd have to live is so extreme. Now, it doesn't mean life couldn't evolve there in some shape or form. We don't know and have no clue if it does, but you can imagine that life would have to be drastically different to sustain iron falling from the sky instead of water or something else.
It's interesting too that it's tidally locked to its parent star, so it only ever, like Mercury, I guess, it only ever has one side facing the sun.
That's right. So there's only one side facing the sun and one side completely in nighttime. So the daytime side always has iron gas to breathe in. The nighttime side has iron rain continuously. So, in some of these planets that have been figured out that are tidally locked, we've theorized that the best place that life would form is on that borderline, right? Where you could have a life form that migrates between the daytime and nighttime. But here you would migrate between breathing in iron and having iron falling on you. Like, it's not a good scenario either way.
Which one would you choose?
Yeah, look, God. I mean, you would hope that you could build big structures enough that you could withstand the iron rain. But if you can adapt to breathing in iron, you can imagine you're almost pretty much like a dragon if you can somehow set that on fire. Like, if you can breathe out molten iron, that would be pretty bad. It's
a pretty cool discovery too, and finding out these things and being able to get really specific on what these exoplanets are doing.
That's right. As we've talked about, this is going to happen more and more, is figuring out the atmospheres and what the planet's actually like besides its mass and distance from the star, because that's the big question. And every time we keep doing these experiments and measuring them, we keep finding dramatically different places no one would have thought this thing existed, right? This is the sort of thing on the checklist of planets that may be out there. This was, in a distant in the thousands in terms of things you would find. This was not high up in the list yet. It's been found.
And I love, here's another acronym, and then it's sort of become a bit of a theme or a bit of a subplot in our Talkin' Science series is finding these funny acronyms that astronomers come up with. The observations here were found from the Herschel spectrograph for rocky exoplanets and stable spectroscopic observations. It's not bad on my first read. Its acronym is espresso. Someone was a bit thirsty in the morning.
That's right. Built by an Italian collaboration as part of the European Space Observatory. That's right. It's perfect, right? You gotta have the good acronyms in order to have the instruments. That's the critical part.
I love it.